assessment of a structural model or inner model refer to relationship between variable in our framework. But assessment of measurement model refer to assessment of relationship between observed items, observed indicators, and construct. So measurement model refer to inside the construct when we talk about something, when we evaluate the relationship between observed item to measure a specific construct, we refer to measurement model or outer model. But inner model or structural model refer to relationship between variables and should be supported by a structural theory, right? So inner model and the structural model refer to between construct and should be supported when we write literature review, and when we hypothesize this relationship should be supported by a structural theory, right? Okay, for assessment of a structural model, there are several criteria in the literature, but some of these criteria are more important and more common for assessment of a structural model. One of the main criteria for assessment of a structural model is coefficient of determination, or R square. Like multiple regression, R squared is very important criterion to assess validity or prediction oriented of our framework. Prediction capability of our framework. So R square is one of the main criteria for assessment of a structural model. We already discussed R square. R square is a ratio of explained variance by independent variable divided to total variance of DV, or endogenous construct, right? So based on R square, we can understand how many percent of variance of dependent variable or variance of endogenous variable come from independent variable, come from antecedents, right? So R square is one of the most popular also criterion for assessment of a structural model. So when we want to assess a structural model, the first thing that we look at is R square and see how many percent of variance of DV come from IVs. Another criterion for assessment of a structural model is size and significance of path coefficient or beta coefficient. In multiple regression also we discussed this one. To assess relationship between independent variable and DV, we check beta coefficient and significance of beta coefficient, right? So we measure significance of beta coefficient or calculate significance of beta coefficient based on different criteria like t-value or p-value and confidence interval, right? So for assessment of a structural model, second criterion is assessment of significance of path coefficient or beta coefficient, right? Another thing is sign of path coefficient. So here we can say sign and size of path coefficient. Size of path coefficient is exactly connected to significance of path coefficient. If beta coefficient or path coefficient is high, so the size of path coefficient is high, so this perhaps should be significant. But also we need to check sign of path coefficient. Sign of path coefficient is positive or negative is depend on our hypothesis. So based on sign of path coefficient, also we can decide the that these hypotheses can be supported or should be rejected based on our result, right? For example, if our hypothesis is one tail and positive, we said the attitude has a positive effect on intention to purchase green product. So this is our hypothesis. But the result is negative and significant. It's significant, but it's negative. So the sign is different with our hypothesis. So still we cannot support this. Our result and our data cannot support this hypothesis. So the second criterion for assessment of a structural model is size and sign of hat coefficient or beta coefficient. Another criterion is effect size. Later I will explain and define effect size. What's the meaning of effect size? Another one is predictive validity or predictive relevance, Q square. And in the recent literature, especially when we apply PLS, recent literature suggests the assessment of out of sample prediction. R square and Q square are in sample prediction criteria. But the recent literature recommended to apply out of sample prediction criteria and using a PLS predict for PLS when we apply PLS for assessment of structural model, right? But this one still is underdeveloped and is not stable and consensus opinion about this one in the literature. There are some recent literature that recommended this one, but still need to develop some criteria for assessment of prediction oriented actually capability of model using out of sample criteria. Okay, so but the four first criteria are important criteria for assessment of structural model. And you need to report in your group presentation and your assignment for assessment of a structural model. These four criteria, right? But not this one, PLS predict. Okay, assessment of R square. R square we already discussed in multiple regression, but again, what's the actually criteria for acceptable R square? Literature suggested different criteria for assessment of R square. Why? Because of actually the value of R square in different area of research. For example, if in marketing and when we want to assess success factors of, for example, success factors of performance. When we assess success factors of performance, we are supposed to include all success factors of performance, right, in our framework. Because we want to assess success factors and see which factor has the highest effect on performance, right? So in this case, when we include all factors, all antecedent, all independent variable that predict or affect on a dependent variable, so we are supposed to get high R square. But in most of behavioral science studies, we don't include all factors. Only we include a few factors, and we want to investigate the effect of these few factors on, for example, intention, for example, in behavior, right? So we develop a framework based on some independent variable that affect on dependent variable. it doesn't mean that there is not any other factor that influence on intention. There is not any other factor that influence on support or behavior. It means in this study, based on some logic, based on some theory, and based on objective of our study, we include these few independent variables, these few variables, right? So in behavioral science, that we are not supposed to include all independent variables, the threshold and the criteria for R square is totally different. So because of that, if you look at the literature, you can see different threshold for R square. For example, in this study, Chin suggested the 0.67 and higher as a large number, large value for R square. Between 0.33 and 0.67, so between these two, the R square is moderate. Between these two, the R square is weak. And lower than this one, so the R square lower than 0.19 is not acceptable based on this criteria. But these criteria are not actually applicable for all type of research. We also have, for example, this one, Cohen, and also Hale in his book, right? Hale et al. When you work in quantitative research, you use a lot in this Hale et al. For different types of research. So they suggested these values. So here you can see the R square higher than 0.26 can be considered high, right? Substantial. And the R square lower than 0.02 is unacceptable. But the R square higher than 0.02 can be acceptable. So this is in behavioral science. And also Hale mentioned, and many literature mentioned in behavioral science, the value of 0.2, the value of 0.2 and higher can be considered high for R square. Can be considered high for R square. So the R square, the value of R square and threshold for R square depends on your area of research, depends on your framework, and depends on previous studies. So you can identify what previous study found in some studies similar to your work. Or your work belongs to what discipline? You are supposed to add all independent variable or only a few independent variable based on your objective. So based on this criteria, you can identify acceptable value for R square. And again, in behavioral science, the value of 0.2 can be considered, based on many literature, can be considered high and acceptable. So this is the some discussion about R square. So we need to evaluate R square, but the criteria for evaluation of R square is different and varied for different types of studies. Second criterion is size and sign of path coefficient. Size of path coefficient, we have some literature that discuss size of path coefficient. For example, some studies say path coefficient or beta coefficient should be at least 0.2. And 0.2 is Based on this, you can identify explained variance of each construct, independent variable, on dependent variable. For example, if you have 3 variable here, and this 3 variable influence on y, okay, if path coefficient is here is 0.2, means this x1 roughly as 0.04 or 4% to the power of 2. 4% of variance of y is explained by this construct, explained by x1, x2, and x3. If the path coefficient is, for example, 0.3, so the explained variance of y by x3 is 0.3 to the power of 2. So is 0.09 or 9%. So based on this, roughly we can identify the contribution of each construct, each independent variable on dependent variable. But actually there is not a suitable way to assess size of path coefficient. The best way to assess size of path coefficient and the importance of path coefficient is based on significance of path coefficient. So you can understand something based on size of path coefficient, but it's better to apply criteria to assess significance of, to calculate significance of path coefficient. So if path coefficient or beta coefficient is significant using p-value, t-value or p-value, or confidence interval, so we can conclude this path coefficient is significant, so the effect of x1 on y is significant effect. So for assessment of path coefficient, first criterion is assessment of size of path coefficient or significance of path coefficient, significance of beta coefficient. Exactly same as multiple regression, right? So different criteria, there are different algorithms to calculate significance of path coefficient that we actually already work with and use this criteria in multiple regression, right? This significance of path coefficient also is identical with the hypothesis testing. So when we assess significance of path coefficient, it means we assess hypothesis and see our hypothesis can be supported based on our data or cannot be supported, right? The third criterion to assess a structural model is effect size. Effect size or F square is a criterion that developed to assess power of each construct, to create or to generate variance of endogenous variable. For example, if we have 3 variable, that this independent variable influence on dependent variable. So we have x1, we have x2, and we have x3. Here we have y. Effect size, addition to significance or size of path coefficient, can show us how many percent of explained variance of y. Explained variance of y. R square is explained variance. Explain the variance of y divided to total variance of y, right? Explain variance of y divided to total variance of y. But this explained variance comes from these three variables. Using f square, we can identify how many percent of this explained variance come from x1, how many percent come from x2, and how many percent come from x3. So we can understand the importance of each variable to create dependent variable, to predict dependent variable. So we can understand the power of this relationship. We can understand the power of each predictor to predict dependent variable. So based on effect size, we can compare the power of these three variables together. We already done this based on the value and the size of beta coefficient, the value and the size of a path coefficient. This is another criterion, addition to size of path coefficient, to identify the importance of each variable to predict or to identify, to predict or to explain dependent variable. So effect size is another important criterion for assessment of a structural model. This is the formula to calculate effect size. To calculate effect size, we need to calculate our when a specific construct included in our framework. Okay, for example, if you have a game, these three, this one, okay. For example, you want to calculate f square of x1. So f square is r square included. R square included, right? R square included means the value of R square when we include x1 minus R square excluded. This one, if we remove x1, right? If we remove x1, R square will change, right? So when R square change, this will be R square excluded. When we exclude this construct, this variable, what will be the value of R square? So R square included minus R square excluded, exclude 1 minus R square included. So this is the formula to calculate f square for each variable. So based on this, we can identify contribution of x1 in R square of latent, R square of endogenous construct, dependent variable. So the value of f square is, it's large if the value of f square is higher than 0.35. Between 0.15 and 0.35 is medium or moderate. Between 0.15 and 0.02 is small. And lower than 0.02. F square lower than 0.02 is not acceptable. Sometimes we have significant path coefficient. The effect of x1 on y is significant, but the F square is lower than 0.02. In this case, recent literature suggests to reject hypothesis. So if you want to report F square and the value of F square is very low, even your path coefficient is significant, you cannot support this hypothesis. If F square is lower than 0.02, for example, is 0.01, what does it mean? What does it mean? Anybody can interpret this value? Any answer?
What is the value, Prof?
0.01.
0.01 for effect size. So
yes.
That means we have to reject, because even if the path coefficient is significant, but the effect size is very small.
Yeah, but the very small effect size, what's the meaning of very small effect size?
There is no impact of that particular predictor on Y.
Yes. Yeah, it's correct. So it means the contribution of this construct on R square of dependent variable is very low. Here is, we can say is about 1%. The contribution of x1 and R square of latent, R square of dependent variable. So this value is very low. This contribution is very low. So it means x1 cannot contribute on variance of dependent variable. So we cannot accept the effect of x1 on y, right? So this is beside the path coefficient, this is very important criterion for assessment of structural model. Okay. Also Q square, I didn't put Q square here. Q square, based on some algorithm, we calculate Q square using blindfolding bootstrapping. Especially when we apply PLS, because PLS is a prediction-oriented technique. So we need to apply some criteria. Q square is one of the criteria to assess prediction relevance of our framework, our model. So using blindfolding bootstrapping, we calculate Q square, and the value of Q square, should be higher than 0.3. Should be higher than 0. Sorry. Should be higher than 0. Q square can be negative. So if Q square is negative, means our model has not acceptable predictive validity, acceptable predictive capability. So we cannot accept predictive validity of this framework. But if Q square is higher than 0, is acceptable. The higher, the better. So Q square higher than 0.36 if I'm not mistaken. 0.36, higher than 0.36, consider very high. So these criteria, if I'm not mistaken, these criteria also applied for Q square, but not lower than 0.02. Still, when is higher than 0, Q square is higher than 0 is acceptable. So only we need to check this one. But the higher the better. When the value of Q square is high, means the predictive validity, predictive capability of our model is higher. Right? So this is another criterion, and different software also provide these criteria. R square, size and sign of path coefficient, F square or fx size, and Q square. So you can get these criteria from the software and report based on the value of these criteria. This is an example from one of my papers for assessment of a structural model. Here you can see, for example, for this one. For this relationship, right? For this relationship, effect of economic gain on negative perception. So you can see, I hypothesize this relationship as a negative relationship because based on literature and based on theory, we thought economic gain should have negative effects on negative perception, right? But here, the result is positive, 0.127. The p-value is 0.01, right? So 0.01, right? So it's significant, but the sign of path coefficient is different with our hypothesis. So here we cannot support this hypothesis. We have to reject this hypothesis. So supported no, because of different sign. So this is a way to report the sign of path coefficient. For other one, for example, for first one, community attachment on positive perception, path coefficient is 0.09, p-value is 0.05, and supported, yes. Because the sign of path coefficient is identical with the sign of hypothesis. But if the sign of path coefficient is different with the opposite of hypothesis, even for significant path coefficient, we cannot support this hypothesis, right? Also, you can see here, for example, effect of facility on perceived crowding, 0.34, it's very high. And the p-value is lower than 0.01. But because of different sign, because in this paper we hypothesize negative effect, but here is positive, so we cannot support this hypothesis, right? So this is a criteria for assessment of measurement structural model. Here, I actually put some plots from SmartPLS. In SmartPLS, I will show you the relationship between variables also can be non-linear. This is linear. And we discussed before multiple regression, linear regression. So if the relationship is something like this, is linear. But also the relationship can be non-linear. Here you can see the relationship is U-curve. The relationship is U-curve. The relationship can be quadratic, can be logarithmic, can be U-curve, and can be S-curve, for example. In logistic regression, if you remember, we discussed about S-curve relationship. And we said it's not possible to apply multiple regression for dichotomous DV because the relationship is non-linear and S-curve. Right? But it's not common in different studies. Most of social science disciplines apply linear relationship. But actually, in reality, most of relationships are non-linear. We don't have linear relationship, right? So we simplified relationship to linear. We can apply nonlinear algorithm, especially in SmartPLS. SmartPLS is very powerful in this feature and can give plots for all relationships. I will show you later. So this is one type of nonlinear relationship. For assessment of a structural model, the first criterion is R-square. Again, if you go back to this result tab, you can see R-square here. If you click on R-square, okay, you have R-square and R-square adjusted. So you can report R-square or R-square adjusted for your endogenous variable. Also, you can get R-square from this figure. If you want to present this figure, assessment of a structural model result, or your result figure, you can save this figure and copy and paste in your, or present in your thesis and the paper. How? If you right click on, after you perform PLS algorithm, if you right click on this page, right, here you can see two options. Export as image to file, so you can save as a file, and export as image to clipboard. You can save, you can copy and paste in your report. Okay, for example, if I click on first one, all are transferred to the folder that I imported my data file from, right? So here is in data assignment, for example, structural model results, right? So you can say, you can choose different options, JPEG or PNG, or the default is PNG. So click on save. And if I'm going to this data assignment, here I can see a structural model result. If you click on this one, this is the figure of your structural model. If you click on right click and export as image to clipboard, for example, if I have this file, okay, this is figure 1, result of assessment of structural model. So just can I paste here, and this is the result that I have. from the software. So you can copy and paste result in your thesis and your paper. Addition to table, right? Okay. So the first criterion for assessment of a structural model is R square. So you need to report R square in your table, or it's common to report R square just in text, right? For example, if you look at this paper, when we start to report assessment of a structural model, yeah, but this paper is MGA, so we focus more on MGA. Okay, so assessment of a structural model. So in this paper, we discuss R square at the beginning of assessment of a structural model. And we reported the value of R square. And here we explain in behavioral studies, a value of 0.2, if you want to cite and you want the publication to cite, 0.2 for R square in general considered acceptable. And this is two citations that we cited, right? So we can report the value of R square in the text. No need to put in the table. But in some papers also we put in a table. Let me see. I can find. So there are different types of no, I think in this paper that I have here, just I reported in text. The best way is report to text, but still you can put, if you wish to put in table, for example, in hypothesis testing, the end of hypothesis testing, you can create another row and explain R square. This paper, okay, so this is for reporting R square. But the next criterion for assessment of a structural model is size and sign of path coefficient. Here we can see size of path coefficient as sign of path coefficient. But we cannot see and we cannot find the result of significance of path coefficient. Okay, here the first path coefficient, first beta coefficient or relationship between community attachment and support is 0.21, 0.14, 0.036, and 0.315. But you don't know these relationship and these path coefficient are significant or not. It's not possible to get result of significance in this PLS algorithm part. Right? To get result of significance of path coefficient, we have to run another analysis. Click on calculate and run bootstrapping. You remember for SPSS, if our data is non-normal data, we had to run bootstrapping for non-normal data. But in PLS, this is a common practice. Always we use bootstrapping to calculate significance of path coefficient or other estimated parameters. So PLS is a non-parametric approach because always we apply resampling method. We apply bootstrapping method. So PLS is very good to work with non-normal data. because bootstrapping is part of method to estimate parameters, to estimate or calculate significance of parameters, right? Okay. So for bootstrapping, you need to click on bootstrapping. Okay. Here you have several options. No need to check and change anything in partial least squares, missing value, and weighting. But here you need to select number of resamples. Number of resamples, the recent literature suggests 5,000. But if you choose 5,000, it takes long time to perform analysis. For last analysis, you can choose 5,000. But when you want to do some practice and do some work to get familiar with software, you can choose smaller sample, smaller resample. For example, 500. Here you have two types of bootstrapping: basic bootstrapping and complete bootstrapping. Basic bootstrapping give you significance for some basic parameters like path coefficient, outer loading, outer weight. But if you want the significance of a very advanced feature like goodness of fit, like R square, you need to click on complete bootstrapping. But now only we need basic bootstrapping. Here also there are some advanced features for different types of confidence interval. So ask you what confidence interval you want. The default is bias corrected and accelerated bootstrap. So you can keep this default. And also you can choose one tail or two tail based on your hypothesis. If your hypothesis is one tail, you can choose one tail. If your hypothesis is two tail, you can choose two tail. So I choose one tail, right? And start calculation. Okay. So another tab will be open here. Before we had data, pad model, PLS algorithm, and now we have bootstrapping. In bootstrapping, you can see result of significance of path coefficient, right? Okay, if you click on path coefficient, click on path coefficient. Here you have different options. First one give you t-value and p-value. Second one give you confidence interval. And third one give you confidence interval bias corrected. So you have three options to report significance of path coefficient. Recent literature, you can use bias corrected, also either bias corrected confidence interval or confidence interval. They apply different algorithms, right? But the recent literature suggests that confidence interval bias corrected is more reliable. So you can choose this one to report, right? So to report significance of path coefficient, you have t-value here and p-value. Again, p-value lower than 0.05 is significant. Here, significant p-value is green. Only one is red. So the effect of economic gain on support is not significant. Also, you need to check confidence interval, and similar to multiple regression, confidence interval, if includes 0 or 0 fall in this range between lower and upper levels, like this one, like economic gain on support. Here, this one includes 0. So it means this relationship cannot be supported and is not significant. Also, you can see in this p-value. But if this relationship is, if this range is not, 0 is not between lower and upper levels, so it means this relationship and this path coefficient is significant and this hypothesis can be supported. If you go to path model, again here in this tab, you can see the result of bootstrapping. Now you have two results, PLS algorithm and bootstrapping. And also you can transfer bootstrapping to Excel file to use it. If you click on Excel, again, bootstrapping. So the result will be transfer and can be used. Okay, so this is the result of bootstrapping. If you go to path coefficient, for example, okay, here you can see the result of t-value, p-value, confidence interval bias corrected. Exactly same as result here, but you can see the result in Excel format. Okay, so this is for assessment of a structural model. For reporting result in for assessment of a structural model, it's good to create a table. You already reported the R square. So in this table, you can put your hypothesis and path coefficient and p-value and supported, or you can put yeah, here you can put path coefficient, confidence interval bias corrected. Here we only choose to decided to use the confidence interval bias corrected, not p-value, and reported based on this result. Okay. So this is the second criteria for assessment of a structural model. Third criterion is effect size. Effect size also you can find here in PLS algorithm part. Okay, here you have F square. If you click on F square, this is effect size for relationship between community attachment and support, economic gain and support. And also in table, PLS regression, PLS algorithm result. Here, if you click on F square, okay, you can see the result of F square here. For first one, F square is small. Second one is not acceptable and significant. Third one is small, and involvement is higher than others. So you can see involvement has highest effect on support, right? If you want to add F square, it's good to add to hypothesis testing table. For example, here in this table, we included effect size. So you have path coefficient, you have p-value or confidence interval bias corrected or confidence interval, and you can add effect size. And report result of hypothesis testing based on effect size and based on path coefficient and significance of path coefficient. Okay, so this is for assessment of measurement model and structural. The last criteria for assessment of a structural model is QS square. To perform QS square, you need to go to blindfolding. If you click on blindfolding, no need to change this omission distance, but this can be between 5 to 11. But 7 is fine, no need to change. Start calculation. Okay? So here you will have the result of blindfolding and QS square. Only you need to report this QS square, not this result. So the QS square for support is 0.21. Is higher than 0, is higher than 0, and is very high. So based on this, we can confirm predictive validity of our framework, our model.